In this video, we're going to talk a little bit about the inverse properties of logarithms. Now, the definition of a basic logarithm is that if y equals log base b of x, then b to the y equals x. These two are inverses of each other. So remember, if we compose inverse functions, we get back to our input. So log base b composed with b to the a equals a, because those two bases are the same. So this is composing inverse functions. We're composing a logarithm with an exponential. Here, we're also composing the two, except now the input is a logarithm, the inside function is a logarithm, the outside function is an exponential. So if we have b raised to the log base b of a, it's equal to a. So let's see how this property applies. So if we have log base 3 of 3 squared, these bases are the same. We're composing inverses, so it's just simply equal to 2. We'll do a few more here just to get used to this. So log base 4 of 1 over 16. Now we don't have the bases the same, but we can write 1/16 as a base 2. So log base 4, 1/16, well, 16 is 4 squared. Because it's in a denominator, we're going to write it as 4 to the negative 2. So this is equal to negative 2. So that's how this property works, even if what we have up in the exponent is an expression. So log base 5 of 5 to the x plus 3 would be equal to x plus 3. So that's our inverse property, and it works in both directions. So if I had 5 raised to the log base 5 of square root of 2, that's equal to the square root of 2. Let's do a little tricky one here for our last one. What if we had something like this: 16 raised to the log base 2 of x? Because right now these don't have the same base. 16 can be rewritten as a base 2. So as a base 2, this is 2 to the 4th, and that's being raised to the log base 2 of x. Alright, we can't quite use the property yet, but what happens when we have an exponent raised to an exponent? They multiply. So this can be rewritten as 2 raised to the 4 log base 2 of x. We still can't quite use the property yet, but we're getting close. It's this 4 out front. But remember, we have a property of logs that allows us to pull the exponent out front. We're going to go the reverse on that property and put it in as an exponent. So this is now going to be rewritten as 2 log base 2 of x to the 4th. Now we have the same bases, there's nothing in between, so this is equal to x to the 4th. So we ended on kind of a tricky example there.